Let's start with our first question. The first question over here says, a projectile is fired from the surface of the earth with a velocity 5 meter per second at an angle of theta with the horizontal. Another projectile fired from another planet with a velocity of 3 meter per second at the same angle follows a trajectory which is identical with the trajectory of the projectile fired from the earth. Great. The value of the acceleration due to gravity on the planet will be how much? Okay, let me explain you first what the question is saying, that you are having two planets. Let's say this is the first planet and this is the second planet. Planet A is Earth and planet B is any random planet. Now you are throwing a projectile. What's a projectile? Any object you are throwing, a ball, a football. Okay. So if you are throwing any object on Earth and you are throwing the same object on any other planet, the trajectory, the path followed by both the planets, on both the planets, the path followed by the particle will be same. So let's see what is the equation of path, right? We have already done the equation of path in our projectile motion. And what is our equation of path? It says y equals x tan theta minus half gx square upon u square cos square theta, right? This is our equation of path. Now let's apply the conditions. First of all, if the equation of path is same, then we know that our y and x in both the cases will be same, right? Then only it will. And theta, the angle of projection, is also same. So let's say for the earth, ye is earth, that will be equals to xe, tan theta, that will be equals to minus half g, acceleration due to gravity on earth, x square xe square upon ue square cos square theta. Now be very careful here. The condition here is the path is same. So if path is same, which means we can write similar for the planet. So yp, and this yp will be equal to the same as on the earth. So let me write it ye only. Xe also same. Angle of projection is also same, minus half g. Now be very careful, acceleration due to gravity on that planet will be gp, and xp square upon up square cos square theta, correct? Now what is ue? Ue is the velocity of that projectile on earth, and what is up? Up is the velocity of projectile on that planet which you are throwing on, right? So if both the y's are same, so let me just write here xp, it is xe, correct? So let's equate the green and the purple equation or the pink equation. So when you equate both, it will be xe tan theta minus half ge xe square upon ue square cos square theta, and that must be equal to xe tan theta minus half gp xe square upon up square cos square theta, right? Let me repeat again. You are throwing any object on the earth, you are throwing the object on the planet, the trajectory is same, the angle of projection is same. Okay, so we can write that trajectory is same means what? So what is the meaning of trajectory? If the trajectory is same, our x coordinate and y coordinates are same, right? At each and every instant, the x coordinate and the y coordinate followed by the particle will be equal, right? So let's cancel out xe tan theta on xe tan theta both the sides, minus half ge xe square upon ue square cos square theta, that must be equals to minus half gp xe square upon up square cos square theta, right? Now let's cancel out our half minus half and minus half cancelled. Xe square will cancel out because x and y coordinates are same, that's why the path is equal, right? And cos square theta will be equal to cos square theta. Now gp we can rewrite it as, let's cross multiply, so we will left with ge into up square upon ue square. Let me remind you once again, ge is the acceleration due to gravity on the planet earth, and that is we already know it's 9.8. And what is up? The velocity, the initial velocity of the projectile with which you are throwing it on that particular planet. So up we can find it as 3 meter per second as per the question. You can see here it's 3 meter per second on the planet and 5 meter per second on the earth. So let's substitute the values here. It will be 3 3s are 9 upon 5 5s are 25, correct? So when you simplify, that will be equals to 3.5 meter per second square, right? So when you simplify this value, you will get 3.5 meter per second square, and that is option A. I hope this is clear. If it is not clear, please go back and watch it again. Okay. Great. Let's see the next one. Our next problem says a particle is moving such that its position coordinates x, y are 2 meter and 3 meter at any time t equal to 0, 6 meter and 7 meter at t equal to 2 seconds, and 13 meter and 14 meter at t equal to 5 seconds. What will be the average velocity from t equal to 0 to 5? So, let me just write the given data. At t equal to 0 seconds, the particle's location was 2 meter, comma 3 meter. If you want, you can write it as 2I plus 3j, that is fine, you will get the same. At t equal to 2 seconds, we can write it as 6 meters and 7 meter, that is the location, right. And the coordinates for t equal to 5 seconds, it is 13 and 14, right. Again I am repeating, the times is given in seconds, okay. Now, they are asking us average velocity. Now, average velocity will be dependent on the displacement, right. And in displacement, be very careful, we just focus on the initial and final position, because they are saying t equal to 0 to t equal to 5. So, when you are going from any point A to any point B, you do not care about what path you are taking, you are just focusing on initial and final coordinates. So, the displacement here will be, the average displacement will be, the net displacement will be 13 minus 2, that is 11 I cap, and 14 minus 3, that is 11 j cap, right. Let me repeat again, we just subtracted the final x coordinate x2 minus x1 and y2 minus y1, right. In case if you are not familiar with the displacement vector, let me write here delta r, that will be equals to x2 minus x1 I cap plus y2 minus y1 j cap. Be very careful here, we are dealing with displacement vector, right. So, we just focus on the initial and the final position, we do not care about what other places the particle went in between the initial and final position, right. So, that is our displacement and net displacement you can say. And what will be the average velocity? Average velocity will be equals to this displacement 11 I plus 11 j and whole divided by, what is the total time to cover this? Said from 0 to 5, so it is 5 seconds. So, we can take 11 by 5 common and you left with I plus j, that is option D, we can directly see here. I hope this is clear, quite easy problem. Let us move to our next problem. Our next problem says the velocity of the projectile at the initial point A. So, our initial point A has, it is a point, so it is not a vector, that will be equals to 2I plus 3j meter per second, right. Its velocity in meter per second at point B. Okay. Now, this is a very simple concept you have to remember, the velocity with which the object is thrown here, okay, the same velocity it will get once it touches the ground, right. So, at any point B, it will get the same magnitude, but do the direction is same? No, because here we are projecting it upward and here it is getting downward, right. So, be very careful, at A and B the directions will change, but magnitude wise it is same. So, if I directly try to figure out the magnitude, I can see that A, B, C, D, all the options will give me the same magnitude. So, that is a little thing where you have to think about. So, at B, I can simply say that x coordinate will stay positive, but y coordinate it is getting downward in direction, right. So, x coordinate will still remain 2I, but the y coordinate will make it negative. Why negative? Because it is going down, right, to keep the overall magnitude of the velocity same. So, that is option C. I hope you understood this problem. Let us see the next problem. Okay, this is quite important and very common question, frequently asked in exams like in your school exams also, okay, but once asked in even NEET exam also. The horizontal range and the maximum height of the projectile are equal. So, h is equals to r. H is the maximum height we say and r is the range, horizontal range. The angle of projection you have to, very common question. So, we will directly place our formulas. H is u square sin square theta upon 2g, right, and r is u square sin 2 theta upon g. I hope this is clear. Now, let us simplify it. U square, g cancels with g, we left with here as sin square theta and upon 2, and the right hand side we left with sin 2 theta. Now, if you are not a math student and if you have done a little bit mathematics, you know that the relation for sin 2 theta is a very simple relation, sin square theta upon 2, that will be equals to 2 sin theta cos theta, right, that is our relation. So we can cancel out sin theta with sin theta, one of the sin theta will get cancelled, and here let us take 2 on the other side. So it will be sin theta upon cos theta, that will be equals to 2 2s are 4. So tan theta will be equals to 4, or you can say that theta is nothing but tan inverse 4. In case if you are not familiar with inverse trigonometry, just remember that when you take tan on the right hand side, it will not become 1 by tan as such, we will write it as tan inverse, right. So be very careful. So the correct answer here is option B, that is our tan theta value, correct. Let us see the next one. Great. Our next problem says a particle has initial velocity. So let me write here u, that is equals to 2I plus 3j, and acceleration, let us write here a vector, both are vectors. So a is equals to 0.3I plus 0.2j, correct. The magnitude of velocity after 10 seconds. So after 10 seconds, so t is equals to 10. Let us recall our very basic equation of motion. V will be equals to u plus at, and let us substitute these vectors. So u is nothing but 2I plus 3j, and acceleration over here is 0.3I plus 0.2j, and t here is 10, right. Let us multiply them, and we will get here 2I plus 3j plus 0.3 into 10, 3I plus 2j, and we will get here 5I plus 5j, that is our velocity vector, right. Let us see the option. Oh great, they have given it in magnitude. So we will have to find the magnitude. So any vector r which is given as ai plus bj plus ck, you can write. Here it is given in terms of 2 only, 2 dimensions. So magnitude of that vector r will be root under a square plus b square, right. So here if this is our velocity vector, we can find the magnitude of v, that will be root under 5 square plus 5 square. Let me recall, how do we add them? Let us call 5 square as an apple. So 1 apple plus 1 apple, so 2 apples. So let us write here 2 into 5 square, right, and this will give us root 2 5. Great. So or you can rewrite it as 5 root 2. So that will be our answer, that is option B, 5 root 2. Clear? Let us move to our next problem. Great. So next question says a missile is fired from a maximum range, with an initial velocity u equals to 20 meter per second. G is 10. What will be the range of the given missile? Now if I write the formula for range, it is u square sin 2 theta upon g, correct. Now be very careful, in this relation we need theta, theta is the angle, right. So if theta is the angle, but it is not saying anything, be very careful, the range will be maximum if the sin 2 theta, the whole trigonometric part will become 1, and when it will become 1, when this whole thing sin 90, which means theta must be 45 degree. So at theta equal to 45 degree, r is maximum. This is the concept here. So r is maximum at theta being 90 degree. So if we substitute here, r will be equals to u square, which is 20 into 20. Sin 2 theta straight away 1, because that is the condition we have taken, and g here is 10. So let us cancel out this with this, we left with 40 meter, that is our range, maximum range of this missile. Clear it is? Option D is correct. Let us see our next problem. A body is moving with a velocity of 30 meter towards east. So let us draw, this is our east direction, and it is moving with 30 meter per second. So I can write it as 30 I cap, just assuming that each direction is our positive x axis, so 30 I cap. After 10 seconds, so let me write here t is equals to 10 seconds given in the problem. So its velocity becomes 40 meter per second towards north. So 40 meter per second towards north. So this is our north, and 40 meter per second. Now in form of vector, I can assume that north is j cap, right. The average acceleration of the body you have to find. Now this will be our, what's our velocity vector? Our velocity vector will be equals to 30I plus 40j, and the average acceleration will be the velocity upon time. So that will be equals to 30I plus 40j whole divided by 10, right. this will be 3i plus 4j cap. That is our acceleration. Now, they are looking for magnitude again. So, I have already explained in the previous problem, magnitude of A will be equals to under root 3 square plus 4 square. And what is 3 square? It is 9, and 4 square it is 16, right. So, 9 and 16, that will make it up as root 25, and root 25 is nothing but 5. So, let me just rewrite it as 5 meter per second. So, or units, okay, meter per second square, sorry, that is acceleration. So, it should be option D, okay, that is our acceleration for this particle. Let us move to our next problem. Our next problem says the speed of a projectile at its maximum height is half of its initial speed, the angle of projection is what? Now, many students, they get confused with this problem by saying, sir, wait, maximum height, the speed must be 0. This is the first thought they get, okay. But be very careful, if we are throwing something in a plane, not in the vertical direction, because in a plane it is a mixture of, we can draw it here, it is a mixture of x and y. So, at this point y velocity will be 0, not x. Sir, how can you say that? If velocity along x axis is 0, let us say at this, after reaching here, the velocity of x axis also becomes 0, let us say, let us assume, then this object will not move any way further, it will straight away fall down. And since it is moving ahead and falling somewhere in the range here, it simply means our horizontal velocity is there, vertical velocity 0. Sir, what is the implications of vertical velocity being 0? It simply means the projectile or the object will not go further in upward direction, but only go further in the front direction. So, Vx is not 0 here, be very careful, and Vy is 0 here. If you are throwing any object straight away vertically up, then Vy is 0, okay. I hope this is clear. Okay, let us come back to the problem. The speed of the projectile at its maximum height. For that, we should remember that Vx, final velocity of any object which is flowing or which is moving through a projectile motion, it must be u cos theta at any instant. And what was Vy? It was u sin theta t, u sin theta minus gt, right, if you remember. But at the maximum height, this Vy will become 0, and we will get the time of maximum height if you have done the derivation, right. So, here straight away Vy will be 0, correct. Now, at the maximum height, our u cos theta is there, right. So, u cos theta, and that is equals to, at maximum height, the speed of the projectile at its maximum height is half of the initial speed. So, we can write it as u by 2. U is the initial velocity, right, with which it was going, and this is this. Now, be very careful. Some people will say, sir, wait, initial velocity, how can you say that it is u? Now, we are equating the magnitude. Here it is u cos theta. If you find the magnitude, you can write it the vector if you want, okay, at any instant will be equals to u cos theta I, and at maximum height 0j, right, and if you find the magnitude, you will get u cos theta only, correct, and that is equals to the magnitude at initial part. So, u cancels with u, and you left with cos theta will be equals to half. For what angle cos theta is half? Theta must be 60 degree. So, at theta equals to 60 degree, cos theta is half. That is our correct part. I hope this is clear. Let us see our next problem. A particle is moving, a particle moves in xy plane according to the rule x is equals to a sin omega t and y equals to a cos omega t. The particle follows. Now, if you have done simple harmonic motion, if you have done oscillations chapter, then it will be straight away, you can just look at it and say, okay. Otherwise, simply add both x square and y square. Let us see what we get. So, adding x square and y square, it will be a sin omega t, both are harmonic functions here, plus a cos omega t whole square, and that will give us how much? A square sin square omega t plus a square cos square omega t. Taking a square common out, you left with sin square omega t plus cos square omega t, and sin square plus cos square is how much? Sir, it is 1 from 10th standard. So, we left with a square. Let us rewrite this equation. So, what we got here is x square plus y square equals to a square. Now, what is x square plus y square equal to a square? Which equation? Sir, equation of circle. So, correct answer is circular path.